Okay. All right, so if you need to go toilet, if you need to get a glass of water or your hot chocolate drink, please type into the chat. I'm taking a drink. I'm going toilet. Do not need to ask for permission. Just inform. Inform me through the chat, and when you're back, just type into the chat. I'm back. All right. This is this month's again National Day promotion. Please continue to share 88 tuition with your friends and family. So 88 tuition has tuition from primary 3 all the way to set 2. Next year they have set 3 as well. All right. So if your friends subscribe, they get 25% off. You also get 25% off. So win-win situation. All right, let's start. Okay, so over here, okay, let me just bring up my Excel file. Some of you have just submitted the assignment just now. Now, if that say it's getting laggy, please leave the chat, all right? And then leave the Zoom, not chat. Leave the Zoom and then come back again. Sometimes the internet, if it's too laggy or suddenly you cannot hear me, right? Then you just leave and come back in. I'll admit you later on. Now, for this question, right? I only have 4 responses. Okay. Now, 2 of you got this wrong and 2 of you got this right. Okay. So this is a simple question. So if you get this wrong, no worries. But after today, please don't get this wrong. Okay, let's start. To increase the temperature of 1 kilogram. Okay, hang on. All right, to increase the temperature of 1 kilogram of copper by 1 degree Celsius, to bring the temperature by 1 degree Celsius, you need 400 joules of heat energy. All right, then they are now supplying heat of 12,000 joules of heat to 2 kg of copper, same material copper. Initial temperature is 25 degrees Celsius. So they want to know what is the final temperature. So I'm basically underlining the keyword, but the most important thing is this. Notice that this is 1 kg and this is 2 kg. All right, so when you have different mass, you cannot do comparison. Okay, yes. Hang on. Go ahead. Of course, Wesley, don't need to ask for permission. Go toilet. All right. Just say I'm going to the toilet. All right. Yeah, of course you can. Okay. Then, Sarabel, your Wi-Fi disconnected. No worries. I will be, the system will alert me. All right. Somebody is leaving and somebody is coming in. I can hear the ding dong, so I will admit you. All right. So Wesley, enjoy your breakfast. All right. When you're back, type I'm back. Okay. So over here, so make it to the same mass. So if I'm going to increase to 2 kg, I'll change it to 2 kg. So in other words, I need to times 2. Therefore, here I will also times 2. So 400 joules will become how many joules? Anyone quickly? Unmute yourself. 400 joules become how many joules? Or you can type into the chat. Thank you, Hein. All right, you have 800 joules. Okay, so you will change the 1 kilogram to 2 kilogram. All right, so in other words, if I will need 800 joules, okay, of heat in order to bring up the temperature by 1 degree Celsius. Okay, so this is for 2 kilogram of copper. Now, by the way, what is the chemical symbol for copper? Can you everyone type into the chat, please? I will try to also weave in similar related topics to the same question. What is the chemical symbol for copper? Hey, CO is cobalt. That's cobalt. That's not copper. Try again. All right, LeBron, good job. Again, Hey, this is correct, except first letter must be capital letter. Ziqi, that's correct. First letter must be capital letter. All right, so the rest, not everybody has tried. Right, so please give me a chemical symbol for copper. Okay, if you don't know, just write, I don't know. All right, what do you write for short form? Okay, IDK, right? You can type into the chat IDK, I don't know. All right, it's okay. So at least I know this is the part that you're not so sure, so that I will help you. Okay, so copper is Cu. Please don't get confused with CO. CO is cobalt. A lot of students get confused. All right, so after today, please don't get confused again. Copper, think of it as copper like Cu. Think of it as Cu. See you next week. Okay, so it's a CU. All right. Okay, back to the question. So I need to make sure that I'm comparing for 2 kilogram of copper. So for 2 kilogram of copper to bring, so here is 1 kilogram. So I will need to change it to 2 kilograms. So times 2 times 2. So for 2 kilogram of copper, to bring up the temperature by 1 degree Celsius, I'll need 800 joules of heat energy. But now the question is supplying 12,000 joules of energy. So you do your mathematics, 12,000 joules of heat energy. All right, so always make sure that it is the same unit on the same side. So over here, you will use the bottom number, divide by the top number times the other side. So you will have 15 degrees Celsius. All right, so initial temperature is 25 degrees Celsius. The temperature rises by 15 degrees Celsius. So your answer will be 40 degrees Celsius. Okay, so this method is usually you will learn it in secondary school. You make sure it's the same unit, joules and joules. All right, then degrees Celsius and degrees Celsius, same unit on every side. So bottom number divide by the top times the other side. So this is what I'm doing here. Bottom number divide by top number times the other side. Okay, so this is the bottom number. This is the top number, and then times the other side. All right, so 25 degrees Celsius is the initial temperature. Temperature will go up by 15 degrees Celsius. All right, it will rise by 15 degrees Celsius. So 25 plus 15 is 40. Final temperature will be 40. Any questions so far? Please don't keep quiet if you don't understand. Or if I'm going too fast, give me the feedback. Right, every one of us is different. All right, so if it's going too fast or too slow, do tell me in the chat. I will not be angry. I will appreciate the feedback. Okay? All right, so if you don't understand, please type in the chat, I don't understand. Okay? Right, this is a space shuttle. Now, this is a space shuttle that enters the Earth's atmosphere. Now, as it enters, it will get very, very hot, intensely hot. Right? Now, actually, let me ask you a question. If today I pay for you to go to outer space, I ask you to sit in a space shuttle, it's like a space rocket. How many of you will take the chance? Would you type into the chat yes or no? Would you take the chance if I pay for your tickets to go out to outer space? I pay for your training course, to be an astronaut. Would you take up the chance to go out to outer space? Ziqi say yes. Hey says no. Okay. LeBron, what does it mean? Titan. Hey, why no? LeBron said, "Oh, I know what you mean by Titan, the submersible." He says scared. Yeah, LeBron is right. No, recently there was a submersible. Actually, you all think of it as submarine, but that one is a submersible. There's a slight difference between marine and submersible. So anyway, that's a submersible. It went deep into the ocean. The deeper you are in the ocean, the higher pressure will be. All right, all the weight of the water on top is pressing on your submersible submarine. So that person, that CEO, wanted to be very, very innovative. So he used a material that nobody has ever used to make submarines. So he used a new material, but that new material, he did not do thorough tests. All right, he did not do thorough tests, so it was actually very dangerous. So that's why initial few attempts to go deep in the sea, they were all safe, nothing happened. But in the last attempt, it imploded. The submersible or the submarine imploded. All right, hi Vidu. All right, long time no see, Vidu. Hope you are feeling, yeah, all okay, everything's good for you. Right, so we are talking about the submersible who imploded recently. Imploded is like explosion, but it's the opposite direction. Okay, explosion is explode outwards. Imploded means explode inwards. All right, so it's called imploded. So they use the wrong material. That material cannot withstand the high pressure deep in the ocean. All right, so about space shuttle is going upwards. The submarine is going downwards. It's just different direction. But for space shuttle, when you go out to the outer space, all right, where it's almost like vacuum, when there's very little air or no air, all right. So when you enter the Earth's atmosphere means the air, it will get very, very hot. So you must make sure you use the correct material to make your space shuttle. So the underneath of the space shuttle is covered with silicon dioxide tiles. All right. So how many properties should these silicon dioxide tiles have? So which are the correct properties that we want for the material to make the space shuttle? All right. So here, brittle, obviously no, right? Brittle means it will break easily. All right. Like glass. Glass is also brittle. All right. Like glass. So obviously I wouldn't want this material to be brittle. All right, now transparent. Do we need it to be transparent? Not really, right? We don't need a transparent rocket, right? Now, high melting point is important. Can everybody type into the chat? What is your understanding of high melting point? Or anybody wants to unmute yourself? What is the understanding of high melting point? Anyone? Right. Yes, yes. LeBron? Is it LeBron?
Melting point, that means it will melt at a high temperature. That means it is heat insulator.
Okay,
Wait.
Iwa. Okay, good job. It means it will melt at a very high temperature. All right. And then Zi say hard to melt. And then Hei say the thing melts at a very high temperature. Well done. So the material, okay, melts at a very high temperature. So not easy to melt, like, in other words. Okay. So it will be very safe. This is very good. I need this. All right. So all right here, but don't write in exam hard to melt. So you need to say it needs a high amount of energy. All right. You need to have a lot of energy to melt that substance. Okay. Now, do you need it to be good heat insulator? All right. Everyone type into the chat. Do you want this property, good heat insulator? Yes or no? Type into the chat, yes or no. All right, type into the chat. Do you want this property? Yes or no? Thank you, Ziqi. Thank you, Heiyin. The rest, can I have a response, please? Not sure, can just type not sure. All right, so at least I know what's going on in your mind. Okay, thank you, Vidu. Thank you, Kirana. Sometimes I may skip names because it jumps too fast. All right, thank you, LeBron, for telling me that. Okay, I need to make a bigger chat window. Okay, so I have a few responses. Ziqi, Heiyin, Kirana, Vidus. Well done. Your responses are right. Now you will need it. Why do you need heat? All right, let me explain. Now, good heat insulator. Do you all know what is the opposite word of insulator? Can you all type into the chat? What's the opposite word of insulator? That start with C. Insulator opposite word will be. Good job, Ziqi. Good job, Vidu. Except spelling, there's a typo error, missing one letter. Good job, Heiyin. All right, the rest is conductor. Okay, so opposite word of insulator is conductor. Okay, so heat, I write heat. Now, opposite of good will be poor. So if I say a material is a good heat insulator, I can also say it is a poor heat conductor. It's the same. Same, All right, as in these two phrases are the same. Because I change heat insulator to conductor, I change good to poor. That means this whole thing, it means the same thing. Now, if I talk about heat, poor heat conductor, it will then gain heat faster or slower. Everybody type here, faster or slower. Type into the chat, gain heat faster or slower, everyone. I expect a response. You either type faster or you type slower or not sure. Okay, thank you, Ziqi, Heiyin, Vidu, LeBron. All right, so it will be, thank you, Kirana. All right, slower. Okay, and then it also means lose heat. What is it? The same answer here? Can you tell me, is it the same answer here, right? Same or different for this answer? Lose heat faster or slower? Okay, good job, Ziqi, Heiyin. Same answer or not the same? All right, so it will be the same answer, slower. All right. So